Okay, so we spent a day talking about how to figure out the combinations. How many combinations can something happen, a process happen. We are going to take that knowledge and go ahead and figure out probability. Now, probability of an event is basically the likelihood of the desired outcome out of all possible outcomes. So what you want over all the ways it could happen. So for example, if you take a multiple choice test and you want to get 100%, what's the chance that you get 100%? Well, how many ways can you actually answer questions on this test? And then that, so 100%, there's only one way to get 100%, and how many ways can you actually take this test? And if you divide those two, you would be actually looking at probability. So P is going to be the number of outcomes in E. E meaning the event that you want, over number of outcomes in S. S means sample space. So for example, it kind of looks like this. So let's say that this is the sampling space. This is like, the test you're taking, or the classroom that you're in, or wherever you are actually taking this probability of. And then E is what you actually want to happen. So then what is the chance that E happens out of all the ways that things can happen in S, or just desired over possible. Okay, let's talk about E a little bit. E is event. So this is the subset of the sample space, which means the desired outcome. Sample space means the set of all possible outcomes of an experiment, and we're going to kind of ignore that. Now, the rules of probability. Probability of an outcome obviously has to be between 0 and 1, meaning 0% or 100%, and everything in between. The sum of all the different probabilities. So number 2, the sum of all the probabilities of all outcomes in sample space. So basically all the different ways that things can happen. If you add them all up, it has to equal 100%. And then number 3, the probability of an empty set is 0, meaning like if you are looking at the probability of you don't, nothing would be 0. Okay, so let's go ahead and test your intuition on probability. So what you can do is pause this video and then try all 5 of them, and then watch this video again to see if you get the correct answer. So if you want, you can pause it right now and then play it later. Okay, so hopefully you tried it out a little bit. So let's look at all the different questions. A, tossing a head on one toss of a fair coin. So basically, probability again is what you want, while you want a head, over all possible, so total ways things can happen. Well, there's only one way to get a head on a coin, but there are 2 faces, so this is going to be 1/2. Okay, next, tossing 2 heads in a row on 2 tosses of a fair coin. So you have this one coin, you're going to toss it twice, and then you are hoping that you get 2 heads. Okay, so again, it's heads over total, but since you're going to do it twice, you're going to have to multiply. Okay, so there's 1 head out of 2 faces times 1 head out of 2 faces, so this is 1/4. Next, drawing a queen from a standard deck of 52 cards. So you want a queen over all total possible. There are 4 queens out of 52 cards, so this is 1 out of 13. Rolling a sum of 4 on a single row of 2 fair die. Okay, so you have 2 dice, and you are trying to roll both of them, and hopefully that you will get a sum of 4. This one is a little bit harder to do, and what I like to do is just kind of draw out a chart. And then we're going to look at all the possibilities together. So for example, the first die is going to go from 1, 2, 3, 4, 5, 6. There are 6 numbers, and then the second one is also going to have 1, 2, 3, 4, 5, 6. So then what you want to do is look at all the possible ways you can get 4, or really just add them up. So you can add this up. 1 plus 1 is 2, and then this is 3, 4, 5, 6, 7. And you can do that for the whole chart, but you can see that there are only a few places you can get 4. This one, and this one. Okay, and then so basically there's 3 ways that you can get 4. And how many ways total can these dice have sums? That is 6 times 6, so that's 36. So that is 1 out of 12. Okay, last one. Guessing all 6 numbers in a state lottery that requires you to pick 6 numbers between 1 and 36 inclusive. Okay, so what does that mean? If you have never seen lottery before, this can be a little hard. So what happens is on a lottery ticket, you have these numbers that go, maybe I'll put numbers instead, 1, 2, 3, 4, 5, and so on, all the way to 46. And what you're going to do is you're going to have to pick 6 numbers. So you pick one number here, and then you pick 6 of them. And then when they actually do the lottery, they will pick 6 numbers, and if you match all 6 numbers, you get the grand prize. So the question is how many, what's the possibility that you actually get it right, get all 6 numbers right? Well, so we would say that this is basically guessing all 6 numbers correctly over all the ways this can happen. Well, let's think. How many ways can you get all 6 numbers right? Only one way, right? Just get it all right. But how many ways can you guess 6 numbers out of 46? So this requires the lesson from 9.1. How many ways can you pick 6 numbers out of 46? That is 46 choose 6. So this is going to be a very, very small chance that you actually get it right, all 6 numbers right. So this is going to be 0.00000010676. All right, so on the previous page, we kind of looked at B, where we said we were tossing a coin twice, and we're trying to figure out probability. And the reason that we multiply the probabilities together is because of this, the multiplication principle of probability. This principle says, suppose an event A has probability of P1. Event B has probability of P2. Under the assumption that A occurs, then the probability that both A and B occurs is P1 times P2. So if you have 2 things happening, it's kind of like the multiplication principle of counting. We have this multiplication principle of probability that says if something happens first and something happens next, and each one has their own probability. And if you want both of them to happen together, then you multiply the probabilities of each together. So let's look at one example. Sal opens a box of a dozen chocolate creams and generously offers 2 of them to Val. Val likes vanilla cream the best, but all the chocolates look alike on the outside. If 4 out of the 12 creams are vanilla, what is the probability that both Val's picks turn out to be vanilla? All right, so the first method is pretty easy. So what we're gonna do is we want to pick 2 vanillas out of the chocolate. Okay, so we are going to, the first method is more intuitive, but the second method is kind of what we want to do later on. So the first time you pick, so let's kind of talk about this. We want vanilla out of total, and we want this to happen twice, so that means we're gonna have to multiply it twice, and then we are going to say how this is basically the probability of how this could happen. Now this vanilla can come out any way it wants, so it could be, you know, this vanilla first and then this vanilla, or this one first and then this one. So then the question is, how many ways can two vanillas come out of two vanillas? So then we had to do, multiply by 2C2. So this part is the probability, and this part is how many ways can this probability happen. All right, so let's look at it a little bit. Okay, so you're going to pick a vanilla out of this box. So what's the chance that you get a vanilla? Well, there are 4 vanillas and there are 12 chocolates total, so 4 out of 12 chances that you will get a vanilla. Let's say you get really lucky and you did get a vanilla. What's the chance that you get another vanilla the next time? Well, let's think about it. If you took out 1 vanilla, there's only 3 left. And out of how many chocolates? There are only 11 left because you took 1 out the first time. Okay, and then multiply by 2C2. How many ways can you pick 2 vanillas out of 2 vanillas? That's going to be 1. So then this turns out to be, this cancels, so that is 4. And 4 and 4 cancels, this is 1 out of 11. All right, now this method 2 is kind of what stats books, you know, that kind of stuff, they would kind of usually write it in this way. So we're going to try to do it this way. Vanilla out of total. Okay, so what is the chance that you pick a vanilla? Or how many ways can you pick vanillas? Well, how many vanillas are there? There are 4. And how many do you want? You want 2. So the question is, how many ways can 2 vanillas come out of 4? So that's 4C2. But what is the total? Total is how many ways can you pick 2 things out of 12 things possible? So 12C2. So then let's use our calculator and calculate this. This is 6 out of 66, which is 1 out of 11. So we get the same answer no matter how we calculate. So let's have you guys try this one. So pause the video, try it, and then come back and write the answer. All right, method 1. So you are trying to get big bombs. So that's 20 possibilities out of 25 cars. And then once you do pick it, you have 19 cars left, and then there are, 19 big bombs left and 24 cars left. And you're gonna multiply by 2C2. How many ways can these 2 cars come out of 2? So you get 19 out of 30. Method 2 is the same. So how many ways can you pick 20 cars out of, 2 cars out of 20 possible big bombs? And then divided by how many ways can you just pick 2 cars out of 25? So that is 190 over 300. Turns out to be 19 over 30 as well. The last thing we're going to do today is look at Venn diagram. So you probably have seen Venn diagram before, but you probably didn't really have to look at probabilities with Venn diagram, but this is a very powerful way to figure out probability. So there's the Venn diagram that we're familiar with, and tree diagram, which is not that hard. It's a very good way to organize data. Let's look at the first example. In a large high school, 54% of students are girls and 62% of the students play sports. Half of the girls at the school play sports. Okay, let's go ahead and organize this information first. So they tell us a few things. 54% of the school are girls. So let's go ahead and draw a diagram for girls. And then it tells us that 62% of the students play sports. Now you may want to draw another one and just write boys, but you actually don't want to do that. You want to just draw a circle to represent what information they give you. So sports. And it actually wouldn't make any sense if you draw another circle that represents boys, because if this school is not a if the student is not a girl, it's a boy, so then you don't actually want to draw another circle. Okay, so let's go ahead and this sample space is basically just at this high school. We're not actually going to look at all the numbers for every single high school. It is just this high school, so we set the sample space within this high school. Now let's go ahead and organize our information so that it goes on the Venn diagram. So first, 54% of the students are girls. Okay, so this circle represents 54. So then everything that's outside of this circle represents boys. Okay, 62% of the students play sports. Okay, so that's this part. So 62% of the students play sports, and then everything outside of that is people who don't play sports. Okay, last part. Half of the girls at school play sports. All right, so let's think about it a little bit. This circle here represents 52% of the school, which is the girls. And then half of that play sports. Half of that play sports. That is this part that overlaps. Girls who play sports. And the question is, how many percent is this one? This is girls who play sports. Well, we know that 50% of the school is girls. Half of the 54% play sports. So this is going to be 27%. Then what does this part represent? This part would represent girls with no sports. They don't play sports. And how many is that? Also 27%. And these percentages that I am writing is out of 100%. So basically, if I add up all these numbers, eventually they have to add up to 100% because this is the sample space. And everything in this sample space in this high school, all the probabilities have to add up to 100%. All right, now let's look at this part. What does this part represent? Well, that little overlap is girls with sports. So what does this leftover part represent? It represents boys who play sports. Okay, so the question is how much of the school, or how many percent of the school is boys who play sports? Now from the question, it tells us that 62% of the students play sports. And then 27% of them, we already figured out, are girls. So then this must be the leftover part, which is 62 minus 27. So that is 35%. Okay, we only have one last part that we have not identified, which is this part that's inside the sample space but outside the two circles. So then you ask yourself, what does this part represent? Well, the only leftover choice is out of girls and sports and boys and sports is boys who don't play sports. Okay, well, the question is how much is that? Now, remember that your sample space has to add up to 100%. So all you have to do is take 100% minus girls with sports, minus girls with no sports, minus boys with sports, and then the leftover has to be boys with no sports, which is 11%. Now that we have this all sorted out, we can answer these questions. What percentage of the students who play sports are boys? That is 35%. If a student is chosen at random, what is the probability that a boy who does that it is a boy who does not play sports? So these percentages that you were writing down, it represents how much the school has a certain kind of situation, but that is actually probability as well, because it's just saying that if you choose someone at random, what's the chance that this thing can happen? So just remember, these percentages are actually probability. So if you choose a person at random, a student at random, what is the probability that it is a boy who does not play sports? And we found out that was 11%. All right, let's look at one where you are going to do this yourself. Okay, so this time there are no categories except for A and B. Okay, so let's look at the question first. A and B are events in a sample space as such that P of A, so probability of A, is 0.6. That means 60% if you want to change it. P of B is 0.5, and P of A and B is 0.3. Probability of A and B means where they overlap. Okay, so I'm going to help you out a little bit in drawing this, and then you can kind of finish it later. This is sample space. You have A, you have B. This part is A and B. This is where they all happen together. So then you have to figure out what the rest of it means and also what percentages each one has. Okay, so pause this video, try it, and then come back and check your answers. All right, so we know that this part, A and B, is 0.3, because that's what they told us. The question is, what do the rest of these places mean? Well, this part means B and no A, right? This is just B by itself without any A's. This part is A, no B. And then the question is, what is the rest? Well, it's just not A and not B. All right, let's go ahead and fill out all our numbers. Probability of A is 0.6. What does that mean? Probability of A is 0.6 does not mean that this part is 0.6. That's not what it means. It means the entire thing is 0.6, because it's not saying that it's just probability of A by itself. It's just saying probability of picking A is 0.6. Now, does it have B? We don't know. It could be, but 0.6 is everything that has A. Therefore, if you just have A by itself with no B, it's going to be 0.6 minus the overlap. So this part is 0.3. Okay, same thing. When it says probability of B is 0.5, that is basically all possible ways of picking B is 0.5. That includes picking B with A inside. So if you want just B without any A, you have to take 0.5 minus the overlap. So that is going to be 0.2. Okay, last thing. We know that the sample space has to add up to 1 or 100% if you change all this to percent. So then the question is, what is the leftover? So you take 1 and then minus the rest, you get 0.2. So now let's go ahead and answer the questions. First, draw a Venn diagram. B, find the probability that A occurs but B does not. A occurs that B does not is 0.3. And then find the probability that B occurs but A does not, that's 0.2.